So let us move on to our exercise now. We are doing exercise 1.2 currently. So in exercise 1.2, the first question is nothing but this particular fundamental theorem of arithmetic. Here you need to express each and every number as the product of its prime factors. So basically you will do what? You will find out the LCM just like I calculated the previous one, and after that you will write down that number is equal to this into this into this. Now if you see any repetition of any number is there, so write down to the power 2 to the power 3, depending upon the number of times the number is repeated. Clear? So I think first one you will be able to do by yourself. Now moving on to question number 2. So before moving on to question number 2, we need to understand one formula. Again, it was given by Euclid only. We can say that the product of two numbers. So when I am talking about numbers, basically I am talking about real numbers. So it can be a rational number, it can be an integer, it can be natural, it can be whole, whatever it can be. So this is the product of two numbers is expressed as the product of its LCM into HCF. And kindly mind it that this particular theorem is applicable for two numbers only, not more than two. So if two particular given numbers are there, if you calculate its HCF, if you calculate its LCM, so the product of LCF and LCM is nothing but the product of the two numbers. Clear? So based on this, we will do question number 2. So question number 2 states that the LCM and HCF of the following integers, find the LCM and HCF, and afterwards you need to do what? You need to verify this theorem. So let us understand how to calculate HCF and how to calculate LCM. This is, suppose I am being given 26 and I am being given 91. So how to find out HCF? We have seen Euclid's division algorithm. By that method we can find out the HCF. But suppose if it is not mentioned in the question that which process I must adopt, in that case you are free to choose any method. Again I am telling you, if the method is not mentioned in the question, you are free to choose your method. By whichever method you feel convenient, you can do the question. So here I am doing the HCF, I am calculating the HCF by other method. Here first of all I am being given 26 and 91. So these are the two numbers I have been given, and I need to find out the HCF of these two numbers. So first of all, before finding out the HCF of these two numbers, you go with the prime factorization of these numbers. So 26 I can do it orally, can be written as 2 into 30. Suppose if the number is very big, suppose the number is 588. In that case you will do what? You will calculate the LCM and you will find out the prime factors. So this is what? This is I have applied division algorithm in this case. Similarly going with 91, so 7 into 13 is 91. Clear? Now going for HCF right now. So HCF is basically what? You will look into the prime factors of each and every number. After that, you will try to find out the common out of them. So the common number is 13. Clear? So HCF, how to find out the HCF? I will write it down separately. To find out HCF, you need to find out the common factors first of all. So write down the common factor. Then go with the power. Now suppose in this case, now in this particular case, we have seen that the power of 13 here is 1, here also it is 1. 13 repeated one time only. Fine. But the point is, suppose somehow if for any particular question you find out that here it is 13 square and here it is 13. So we'll go with the least power. Again I am saying for HCF you will go with the least power of the common factor. So here 13's least power is 1. It doesn't matter from here or from here because both are same. So basically in this particular question we are not able to explain it properly. I will do the next question and accordingly you will be able to understand. So here common factor is 13 and the least power is 1. So this is your HCF. That's all. And in order to calculate LCM, you will do what? You will write down all the prime factors combining these two. So what are the prime factors? 2 is there, 13 is there, 7 is there. So these are the three prime factors I am having. One number is 2, 13, these are same, so I am writing down it once only, and 7. And now you will go with the highest power of each and every one of these prime factors. It doesn't matter from here or from here, it doesn't matter. So you will go with the highest power. The highest power of 2 is again 1, 13 is also 1 and 7 is also 1. So 2 into 13 into 7 is basically what? The LCM. Take this is 26, 182. Clear? Now one example I am taking, one random example I am taking. Suppose any number x is there and any number y is there. And when you are calculating the prime factors of these two numbers, you got suppose 2 3 times, 3 5 times, 7 6 times, 2 4 times, 7 8 times. Okay, suppose 7 2 times. Now I am calculating the LCM. First of all, I'll see what are the common factors. The common factors are 2 and 7. Mind it, when I am talking about factor, I am not looking into the power. I am talking about the base. The base 2, base 3, base 7. Base 2, base 7. So what are the same bases or the same factors? This is 2 and 7. And for LCM, we will look for the least power of these two. Here 2's power is 3, here 2's power is 4. So the least power is 3. And talking about 7, the 7's least power is 2. So 2 3 times is 8, 7 2 times is 49. Multiply these two, you will get what? The HCF of these two numbers. Fine. When talking about LCM, you will go with what? You will write down all the factors which are, means combining these two, you will write down all the factors of these two numbers. So all the factors, writing them down, this is 2, then we are getting 3 and then we are getting 7. Fine, repetition should not be there. And then afterwards, you will go with what? The highest power. Now what is the highest power? 2's highest power is 4. Here it is 3, here it is 4, so the highest power is 4. 3's highest power 5. 7's highest power 6. Find out each and every number, multiply them, and you will get what? The LCM of these two numbers. So hope the thing is clear to you, how to find out LCM and how to find out LCM. Normally what we generally do, if they have not mentioned in the question which method I should adopt, so for finding out LCM, I think this method is preferable. This is my way of thinking. It doesn't imposes any kind of restriction upon you that you have to do it in similar manner only, or the method that I generally choose, you have to choose that particular method only. So in board examinations, we accept each and every sort of answers. So the method is not important over here. It is what? Your convenience. The way you feel convenient, either it is Euclid's division lemma, division algorithm, or this particular method, prime factorization. So coming back to the question was this, that we need to verify that LCM into HCF is equal to product of two numbers. So this is what we need to verify. So we'll do what? We'll calculate LHS and RHS. We'll take both the sides separately because we need to verify that this side is equal to this side. So LHS is what? LCM into HCF. So LCM is 182 and HCF is 13. Find out the product of these two numbers. And in RHS, you are having 26 and 91. Multiply them and you will see both the numbers that are coming are same. Fine. So in the end, you will write down, therefore LHS equals RHS, hence verified. Clear? So this is how you will do the question. Now this particular part, you have to see the question. This is not mandatory that each and every part we need to verify this. If only and only if they are asking in the question to verify, then only you will verify this particular thing. Otherwise, you will simply find out HCF, LCM. Means you will solve the question accordingly. What the question is asking from you, you will solve the question accordingly. You will not do any particular thing from your side. Getting my point or not? So please pause the video to note it down.